Hello everyone. Show it's 1:55, so I'm going to go ahead and get started. This is on-demand build environments with Docker Inception. First things first, my name is James Justinic. My handle on just about everything is Justinic, and I work for a company called Improving. We're a consulting company, and I basically spend most of my time as a developer on a large application, and we've been using Gradle for pretty good bit of time, about since 1.6. So this talk is about some things that I started working on, not related to what I do on my day-to-day job, but something just kind of on the side. So most people now have either used or at least heard of Docker and kind of understand the benefits of that. So the goal there, of course, being that originally when people were building software, there was a lot of unknowns about the environment in which you would be deploying in. Production, QA, staging, all those different environments had a kind of a different environment, and you weren't always sure what you were going to get. Of course, now it's taken off doing the containerization of applications where you're able to kind of ship your entire environment as part of your process. So when we talk about Docker and kind of the relationship to Gradle or to builds, oftentimes we're talking about the usage where we're using it for application deployment. You would make a conscious decision to go ahead and put something in your build, use one of the many Gradle plugins that are out there for this sort of thing, and actually build a container that you can then ship. You can run that locally, you can run that in your production environment. But most of the time, that seems to be what people think about when they think about how can we use Docker for our application. The second way that you often hear about is build infrastructure. And so many of the cloud providers out there that provide CI will give you an environment to say, you want to use this particular Docker image, and then you can run your build inside of that image. There's also, some ability to do that with local on-premise things. I know it was talked a little bit about in the Jenkins talk earlier. So now we're going to get to what I'm talking about. It doesn't really fall into either of those categories. So what I'm talking about is specifically being able to use Docker on your local machine for any build, and basically we're deciding not to touch it and not to do anything that's specifically preparing us for this step that is unique to that particular build. So an example use case you could say here is that, say you have a bunch of developers who, they're still going to be shipping a war file or maybe a Spring Boot jar or something like that. You're not ready to make the jump to Docker, but there's some pain because let's say your application has to run on a very specific version of Java, and not everybody has that particular version installed on their machine, and it might be that they don't want to install that version on their machine. As a consultant, that's often the case that we're using our personal laptops. At a bigger enterprise, you may have a work computer and it doesn't really matter what you do with that. But there's always the opportunity to kind of have a more consistent environment between all the developer machines, whether they be something that you're providing yourself or something that the company could be providing. So this idea kind of came along as me saying, hey, I would like to, take a few steps in this direction, and I kind of landed on three main steps as I did that. So the first step wasn't all that impressive, right? It was saying, okay, we have this thing, the GradleBuild task that we use if we want to call out to another build. That's really easy. It's documented. You can go and look at the user guide or the DSL guide and say, okay, this is how I do that. So first, I'm going to look at just that first step that I took. It's really nothing that impressive, but it's something that will set the basis for the build that we're going to then progress through the next stages. And so this is a pretty simple build here. It's all enclosed in this folder. I have a build.gradle. I'll show you that quickly. And it's nothing other than that task. That task is that GradleBuild task, and it's setting the working directory to the other build folder, and then saying that it's going to run the task build. Now I'm going to look at that other build folder just so you have an idea of what this build is that we're going to run. It is not using any of the normal things you would use. It is here basically to take up time so that as we progress through this talk, you can see what's happening, and we don't want to run too quickly for this case. So it's kind of just a made-up example of something that would take time. So it's called simulate build. It's set up as a dependency of build, and it's just going to loop through there and output each step, tell you what the progress is. And so that one is pretty easy. If we go ahead and run GradleW, if I get the actual build task name right, you can see what it does there. It just runs that task. First the build task from that root project, and then it calls out to the other build and runs build there with its dependencies, and you can see that output. So, like I said, nothing too impressive there. It's just calling out to another build. The next step is pretty similar, but in this time I said, okay, let's take that same idea of running with GradleBuild, and rather than actually go and run a different build, let's have the GradleBuild task actually run the build that you started with. And so you're starting to see kind of that concept of Inception there. If you're familiar with the movie from a couple of years ago, then most people kind of think of it as, oh yeah, dream within a dream, right? But if you think about what they actually described as Inception, it was the concept of going into someone's dream and planting that idea in there. And then when they awoke, they would think, okay, this was my idea. And so it's coming back out. Whereas in the movie's storyline, most the things that were being done by these people that went into the dreams was grabbing information. So this now is getting closer to that concept of we want to kind of go into this other thing and plant something in there, and then when we come out, we'll have what we wanted to start with. So I'm going to go back over to my demo folder over here and switch to the second example. So this one doesn't have that other folder, and it actually has an inception.gradle file there. So that file right now is there just for convenience. We'll take a look at it in a minute, but if you were actually going to do this for something that was more reusable, then of course you would probably put it in a init script in your home directory, or somewhere that's not tied to this build. It doesn't need to be there. It's there just to keep each of the variations that we have of this script lined up with the demos. So I'm going to go ahead and show you that build.gradle file. This file, same thing as the other build in the first example. It's just there to take up time so that we can see what's happening. So I'm going to run this build first in order to just show you what it does. And so no big surprises there. We have the progress and just a normal build. Now, let's take a look at that inception.gradle file and look at what it's going to do. So, little bit of logic here. Very first line there, capturing the information that's in the start parameter. Do most of you, have you used the start parameter to inspect what a GradleBuild is trying to do? Yeah, some. Okay. So what we're doing is we're asking for a new instance of it here. We want to copy. And then in the next step, we're taking that original build request and we're removing our init script because we do want to have a little bit of Inception, but we don't want to kind of, keep going in a nice big loop that we can't get out of. Next thing is in the root project that we have here, we specifically go and create a task called Inception build. This is a Gradle build, but conveniently the Gradle build task allows us to pass it a start parameter object. And so we're just going to pass in the original build request that we got. After that, we want to update the original start parameters for the build that we're running to Inception build. And so that's going to run our task that is then launching that same build with the Gradle build task. And then just for the purposes of if we had a multi-project build, it would get a little messy if we were trying to modify the root project, but the other projects were not, they don't know what's happening to the root project now. So it goes and it says use an empty settings file. Like just treat this as basically I now have a build and it has my task and it's a little bit cleaner for that regard. Now, of course, there are cases where what we have here, if there's some expectation that something would exist in a sub-project that's specifically saying, hey, I want to configure this sub-project, then there would be a bit of an issue there. You'd have to do a little bit more effort to make this thing work. So I'm going to go and run clean just so we can start over. We'll look here and verify that the build directory is gone. Well, we didn't have one, but if it were there, it would be gone. It's a clean build. There's nothing else that's happened there. So now I'm going to run the same thing, Gradle W, but with the init script parameter. And the init script parameter, we're going to specify our inception.gradle file, and then we're going to run build. And so you'll see here that we have a little bit more logging. We have a little bit extra references to tasks. If you look at the top, we have first the Inception build, and then you see that it called into itself. It now is prefixed with the folder that I'm in, which is my second, the Gradle build self example. And then you can see that it ran those same tasks that it did before. Now, at this point, we're not really gaining anything. We've just added some complexity kind of for the sake of complexity, kind of to prove that we could, grab some values and then use them and manipulate our build kind of on the fly. So now I'm going to go back over here to the slides, and technically let's look at the code that we actually have in here first. I'm going to skip a slide here. So we saw this in example number 2, and this, as I described, was basically to capture what we originally started with. We don't want to lose that information. We want to make sure that it gets passed on to the build, and especially once we're in the Docker environment, in that container, we want to make sure that we have this information. Next, we're going to do a couple of setup of files so that we're able to go and actually create something that can then bootstrap this build inside of the container. And so I'm using the properties that are available in Gradle to go ahead and grab my Gradle user home directory, and I'm creating a Gradle Inception folder in there. And so I'm calling it right now the plugin home folder. As we're looking at it right here in this state, it's not wrapped in a plugin, but you can probably see where this might be going. So the second line, we have the bootstrap build file, and that's pretty typical. We're just going and saying, let's create a file that references this bootstrap.build, and we're going to put it in that plugin home folder that was referenced above. And then we want to make sure that all those directories exist, so we call make dirs. So now gets to be the kind of first interesting bit of the code. So if you've used Docker to containerize your application that you deploy, then you probably used one of the community plugins that's out there. In this example, we're specifically using Bends. And so we have several tasks that we need to do. The first step is to call a task of type docker create container. Now, I'm binding several folders here. The first one being to have a particular folder where my GradleBuild is going to be present. This is specifically the mount point for the build that I'm currently running. And so it's going to show up in the container under home/GradleBuild. On the next line, this isn't something that I did initially, but it quickly became evident that it would be quite useful for this. When I first ran this particular trial to see how this would work, almost every time the build took about 2 minutes. And the actual work that I wanted to do only took a couple seconds. And so, as you might guess, a lot of that time was because every time it went out to go download the Gradle wrapper. And that was really, really slow, especially when I was running it the other day on the hotel Wi-Fi. And so I said, okay, we don't need to sit here and watch these builds for 2 minutes. So I went ahead and mounted these Docker containers, it's running as the root user in the container. So I went ahead and mapped the root .gradle folder to a specific location in my current build .gradle folder and gave it a Gradle Docker home. And so that still keeps the isolation that we might be looking for in a Docker container because it is specific to this build. It's not shared across other builds, and so you still would have a clean cache if you wanted it for that build, but we're not having the performance hit that you would otherwise have. The next line for the image ID, I'm just specifying the OpenJDK. That really could be anything that you wanted. In a more plugin-oriented situation, that could be a user-provided parameter, command line, if you wanted to have a separate property file to, provide that value, all okay. Then the command. So the command we want to run once we're in that folder is GradleW, and then we want to provide all of the task names which we provided at the command line when we started this build from our host machine. Now, if you're familiar there, we're taking basically an array of strings, and then we're using the spread operator to make sure that we have all of them listed there, and then we're flattening it to make sure that we just get the one-dimensional array of strings with the GradleW and the task names that we need there. Then the working directory is the home/GradleBuild, which we specified up top. So now we're going to go on to the next task. So we've created the container. Now Docker needs to start running it. And so this is a pretty simple bit of logic, just a dependency on the create build container task. And then we need to specify the target container ID, which was the one that was generated from that task, which it depends on. So our final step here is the task Docker build, and that's of type Docker logs container, and that depends on the start build container task, that one that we just saw previously. We have a bit of logic here. You wouldn't necessarily need to have it, but it's capturing logging. It's making sure that we can see what the underlying build container is doing. We still want that output. Otherwise, it's a black box. We would see a task that says, hey, I'm running your build, but you wouldn't know where it is. With some of the improvements in Gradle 4, the logging and that sort of setup at the command line, there's still some more things that could be done here to integrate with the logging that's produced there. For the purposes of this demonstration, I actually have it showing a typical kind of either console plain or the output that you would have seen in earlier versions. And then we have a setting there for making sure that we tail all, And then once again, we're specifying the target container ID from the create build container task that we had. So now at the very bottom, similar to before, we need to configure a little bit different configuration settings for the build that we're running. And the first thing is to specify that bootstrap build file. And that was the file that we had created above that has a whole bunch of logic in it in order to basically make this happen. That's the build file that's going to basically start the build. And then we say the new task name that we're going to use is Docker build. And once again, we're using that empty settings. So now we're going to go to the actual demo of how this worked. And so I'm going to go to my third demo directory here. We're going to take a look at it. It doesn't look much different from demo number 2. It looks, for all intents and purposes, from what you can see in the folder structure, exactly the same. As far as the inception.gradle file, though, it's a bit more involved than, of course, that first example. So you'll see a lot of the lines of code that you already saw, plus a few new ones. So that bootstrap build file is applying the Ben's Docker remote API plugin that we have. And we're using the build script notation there. We're importing all of the task types that we may need. And then you see much of the code that we already looked at. And that gets written to a file. And so that's everything that's in this inception.gradle file. So now I'm going to go ahead and run this build. First, the normal way. So same thing that we've been looking at. And build is successful. Now I'm going to go ahead and do the same thing, but using this inception.gradle file. And when I do that, we're going to see a bit more action than we've been seeing. So first thing, it creates the build container, it starts it, then it runs Docker build. We have there the information about the build. We see that same output that we saw. But as I mentioned before, we don't see as much from the console as we would normally see in the case of Gradle 4 or even 3.5, or what we're seeing for the root level build there that we started running. And so just to kind of prove here, make sure that there's no crazy logging going on here, I'm going to go ahead and do Docker PS, and you can see here that I've been playing with the build cache Docker container that was mentioned in the keynote. It's running, but we don't care about that one for this. Next, we're going to go ahead and run this build again. And once it starts running, we're just going to take a look at that container, make sure that it's really there like I say. And so let me make it a little bit bigger so you can see it. And so in here we have this one right here, the one that says DDAEC 130923D. It was running with the OpenJDK image, and it was running GradleW with no daemon. And you can see that it was created, and it wasn't up very long, but it ran our build. Now, in the case of a build that you're running, the file system, due to all those mount points that we created, it's shared. So when your build is done, your results are going to be exactly where you expected them to be. The only difference is that the execution happened in the Docker container, and it happened without you needing to install whatever it might have been as far as JDK is concerned, or if there was a case where you needed a little bit more in the environment, of course, you can use any Docker container that you might want to use. Now, go ahead and jump back to the slides. And so I say, what's next? Because this wasn't something that I went in and saying, okay, I'm going to use this and then I'm going to, give a presentation on it. This was something that was kind of developed as I kept having this want to use Docker, but not really a good application or thing that I could apply it to. But at the same time, lots of developers, are saying, hey, I messed this thing up in my environment, but it's not something where, it was an easy fix. It was, some Java update was installed and now they are running, a version that had a slight issue. It was things like that. It was, if you're in a position where you can't use Docker as the way that you build and ship your software, then maybe there's still a way as a developer that you can gain some, good value from it. I've, in recent times, been, really kind of fascinated with the ability to say, hey, I want to go out and try, an installation of Jenkins, a new version. I want to go try, this Nexus server. I want to go try some piece of software. And, it's so easy now locally. You don't have to go in and, mess with setting it up in a folder. You just run the Docker command and then you have that particular application available to you. And so I wanted some of that goodness, but without having to, enforce anything on the build. Now, this is still kind of in its infancy in the sense that it really would probably be best served as an init script plugin. And part of the reason for bringing it here to the summit and talking about it was to get feedback about what you think about this. Do you see that there's value in doing this locally? Are you so far beyond, having applications that you really want to run with Docker? You've already got them all running on Docker, or you've got them running on some, containerized platform, and you're like, I don't need this. I already have my entire environment set up. It was something really to kind of gauge from the Gradle community, is this something that you see value in? And so, based on questions you have, anything that you want to discuss towards the end of this talk, then that's something that will actually meld or mold what the proper direction is for this. And then I would expect it to I'd put some stuff together and publish an init script plugin. Of course, that's less popular than the normal project plugin, but for something like that, it makes a lot of sense since you basically have to do your work in the initialization phase, kind of muck with things to get the environment that you really want. It would still require something on your end where you would say, put something in your .gradle in your home folder in the init.d path or something like that. You could run it on every build if you wanted to. If there was a particular build you didn't want it to, then we can easily have ways to disable it with properties that you pass in. So at this point, I'm really open to questions, for feedback, for kind of figuring out what you think of this. If you think it has a good potential for use in your own environments, or if it's something that you're like, okay, well that was interesting, but I don't really have a use for it.
Question.
Sure.
Your example shows how to pass Gradle tasks to do something inside of the Docker. But what about passing parameters, project properties, and JVM parameters?
So at this point, it's very simplistic in the sense that if you need a specific JVM parameter, right now I don't have logic in there to handle it. That would be something where it definitely, in a plugin released version of an init plugin, it would definitely need to be there. It's something where right now, I basically passed in the minimum for it to work, and it's something where as a plugin, it would need to be there, absolutely. It's not good if it says, okay, you need to check box A, B, C, D, E, and F, then you can use this. Because at that point, you're as restricted as you are with probably your other environments, and it's not a benefit to you. So yes, I don't have an example of doing all of that, but at the same time, I don't expect that this in its form, while you certainly can, I don't expect you to go in like tomorrow and apply this to your project and start using it that way. Not really my intent, but of course, it's available to you if you want to do so.
Thank you.
Sure. Go ahead.
Yeah, we do native builds on Gradle, and to give the developers the right environment with the right tool chain and the right libraries and link against and so forth, we use Docker to contain those dependencies.
And
And right now, a lot of the developers aren't familiar with Docker, and they're not really interested, and so they're kind of resistant to it. And this strikes me as a good way to sort of hide that piece of it. Just let them run a build, and if it goes off, it does it in a container.
So right now, if they want to use Docker for that specialized native environment, they would have to go manually set it up and then go install, bring your code into it and that sort of thing.
Well, it's very simple. They just pull the image, start a container, but they go into the container and they run the Gradle command.
Okay, so they're basically using it kind of like a lightweight virtual
Yeah,
machine.
exactly.
Okay.
And this strikes me as a simplification of that process for them. It seems like
Sure, and it should really apply to just about anything that you would need like that. I haven't tested it on a native environment. I haven't touched native code in many, many years, but it's something certainly community involvement, and if it's something where it's like, okay, here's a plugin, and you want to go and test it with native and see if it works for you, completely open to that sort of collaboration.
A comment and a question. So a use case I can see is we have some projects where the test bench will open a socket, and we occasionally have problems where there's contention for that socket if people are running multiple tests, particularly in CI, right? If the CI server is running two different projects at the same time and they both want the same socket. So this would provide some isolation for that.
Okay.
One question, typically stuff in the Docker container runs as root, and so if it creates build artifacts in the build directory or whatever, those are probably going to come out as root. You thought about that or handled that?
So obviously, you can manipulate things as you want. I didn't have any issues when I was running with the folder. So I would have to go back, I guess, and look at what it was actually creating, but I was able, in just the original test before I went to the simulated build, I had a build artifact and it let me do whatever with it. I went and built from the Docker container and then went and ran clean, from the actual container and did stuff, from outside of the container from my actual machine, and I didn't have any permissions issues. But that's certainly something I would want to look at.
I've tried similar experiments. That's something to watch out for.
Sure. Any other questions? Sure.
Does any of this go to open source, or are you planning to release it?
So I'm planning after the summit, to put some work into it to make it into the init script plugin that you can use. Create some documentation to use it, and then it'll be open source. Published to the plugin portal, that sort of thing, like any typical plugin would be. As far as what open source license, I haven't picked one yet, but definitely open source. And at this point, there's no little fine print like you may use this for this. If you want to use this as it is, I can post a license. If you're in some environment where unless there's a license, you absolutely can't touch it. But that's the sort of thing of from these slides, take what you want. Sure.
It's maybe a bit of a wilder use case, but for some Gradle builds, they may need to themselves spin up containers, like if they're trying to do some kind of tests within a container. Then have you thought about how that might interact if the Gradle build is itself running within a container?
So I haven't really thought much about that particular use case, specifically because my major drive for doing this was the circumstance where people aren't in a position to, be able to use Docker in their, broader environment. And so in that case, I would think you would probably already have the things in place to be able to do a little bit more with Docker, and then this becomes, more of a thing that would get in the way of you being able to, have your optimal Dockerized, environment. Any other questions? Okay, well then I think you get a few minutes left back that you can use to be on break until the next talks. If you have any questions after this, I haven't created a Slack channel for this talk, but my handle, as you saw, is basically the same on almost every contact medium, and it's, direct message me or something any way you want. I will at some point post this, hopefully in next month or two, to GitHub. GitHub handle is the same. You'll see it there when it's there. And happy containerizing.